Welcome back to the Foundry by Forge College. I'm absolutely stoked you're here with us today. Look, if you caught our last explainer on environment setup principles, you've already got the theory down for a rock-solid, reproducible setup. But, well, theory only gets us so far, right? Today, we're taking those abstract ideas and turning them into automated, concrete reality. We're going to dive into exactly how to provision your Solana development environment so you can hit the ground running every single time. Zero headaches involved.
Okay, let's look at the blueprint for this explainer. 1. Bridging theory to practice. 2. Repeatability, clarity, and safety. 3. The kitchen recipe model. 4. Scripting your Solana environment. And 5. The final validation. Let's get right into it.
Section 1. Bridging theory to practice.
We've all heard it. And let's be totally honest here, we've probably all said it at some point. Well, hey, it works on my machine, right? It's literally the classic developer excuse the second a build fails on a teammate's computer or bombs in the CI pipeline. Well, today we are officially bridging the gap from theory to reality to eliminate that exact excuse forever. Having disciplined automated provisioning is the absolute crucial bridge between knowing what a reproducible environment looks like on paper and actually building one in real life. When you script this process, you're not just hacking something together. You are building a rock-solid foundation for your entire team.
Section 2. Repeatability, clarity, and safety.
Okay, so every reliable provisioning setup you ever build has to provide these 3 core guarantees. First up, repeatability. This just means if we feed the script the exact same inputs, it absolutely must give us the exact same output on any machine, period. No surprises. Second is clarity. Your configurations need to be explicit and super easy to discover for anyone reading your repo. And third, safety. This is a big one. Credentials, private keys, API tokens, all of that must be strictly separated from your automation logic. Hit these 3 marks, and honestly, you've got yourself an engineering masterpiece.
Now let's talk about a word that honestly sounds a bit intimidating, idempotence. It kind of sounds like a weird medical condition, right? But I promise it's actually your best friend here. Idempotence is really just a fancy engineering way of saying check before you change. An idempotent script basically checks the current state of your system before it mutates a single thing. So if you ask it to install Node version 16, it first looks around and goes, wait, is Node 16 already here? If it is, it just skips the install. It only takes action when it actually needs to. That means you can run your script 5 times in a row and it won't break your system or cause any crazy side effects.
Section 3. The kitchen recipe model.
I really love this analogy because it brilliantly illustrates how we should approach our environments. Think of provisioning like following a super reliable kitchen recipe. A good recipe gives you an ingredient list. In our world, that's your tool versions. It gives you step-by-step instructions, which is your automation script. And crucially, it tells you exactly when to add your own personal flair or external inputs, like say adding a pinch of salt, or in our case, securely injecting your API keys. If you follow the recipe exactly, you get the exact same dish every single time. No guesswork.
Let's actually look at the ingredients in our kitchen. Our main script, usually something like a provision.sh or a makefile, is basically the head chef. It's the main entry point that applies everything idempotently. Next, we have env.example. This is our template. We commit this to the repository to show exactly what variables we need, but with 0 actual secrets. Then there's the actual .env file. This one is your personal override. It holds your local secrets, it is strictly ignored by Git, and it literally never leaves your machine. Finally, we have tool versions. These are our exact measurements, pinning the precise versions of Node, Rust, and the Solana CLI that we need. Our chef script just acts as a loader, reading all these declarative files and safely bringing them together.
Section 4. Scripting your Solana environment.
Before we go running any commands, I really want to double down on our strict secrets handling policy. Look at this comparison here. On the left side, we have our public templates like config.template or env.example. Think of these as documentation-first artifacts. They're safe, they are intentionally checked into version control, and they act as a guide for your team. But on the right side, you've got your local .env file. This holds the actual, highly sensitive keys. It is completely invisible to version control. The template shows what's required, the override supplies the actual sensitive data. And those two should literally never mix in your repository.
Let's see how all this builds our actual deployment sequence. Imagine you're firing up a totally fresh macOS or Ubuntu workstation. Here's the exact real-world workflow we want. Step 1. We check prerequisites, making sure stuff like Homebrew or apt is actually there. Step 2, we install runtime managers like RustUp or NVM. Step 3, we grab the Solana CLI. Step 4, we create those configuration templates we just talked about. And finally, Step 5, we run a validation check to make sure the whole shebang works. We never just assume a blank slate. Our script reports its status at every single step of this process.
Let's zoom in on steps 2 and 3 for a second, because this is where those idempotent primitives we mentioned really shine. The script reads your tool versions file and asks, okay, do I have node 16? Do I have the stable Rust toolchain? Do I have Solana version 1.14.20? Now, if the installed versions match the pinned versions, the script happily skips the installation. But if they don't match, it reaches out to the official release URLs, verifies the checksums, and installs the exact requested version. No blind installations, no version drift, just a clean, incredibly deterministic setup.
And as we hit step 4, creating our templates, our secrets policy kicks into high gear. If you need a local key pair to test your Solana smart contract, the script should absolutely never generate it and just blindly commit it to the repo. No way! Instead, the script should act like a helpful guide. It copies the env.example to your env, marks the placeholders, and prints a simple, human-readable instruction right to the operator. It essentially says, hey, I need a secret here. Please generate it and put it in this specific local path. It safely guides the user instead of compromising the entire repo.
Section 5. The final validation.
Okay, you should never have to guess if your provisioning script actually worked. You have to validate it. The script should automatically run a few final checks for us. It should verify node.v, Rust C++.version, and Solana.version, just to make sure those tools are actively responding. Then it should try to build a minimal smart contract, or maybe run a tiny test that connects to a devnet endpoint. If everything is configured correctly, the script returns a 0 exit code. Getting that deterministic success message is huge. It completely removes the friction of onboarding. You know without a doubt exactly when you're ready to start coding.
Now, what if you're feeling a little anxious about running some brand new automation script on your pristine, perfectly organized laptop? Honestly, that is a completely fair concern, and that's exactly why top-tier scripts include a dry run mode. A dry run safely evaluates the script and just prints out exactly what actions it would take without actually making a single mutation to your system. It lets you safely review the plan before pulling the trigger. It makes the script totally trustworthy for us human operators, and it's also incredibly useful for reviewing changes in CI pipelines.
So when you run that validation and you see that beautiful 0 exit code, you've officially achieved success. You now have a perfectly consistent, reproducible baseline environment. And as you progress through your learning and courses with us here at Forge College, you'll see pretty quickly why this is absolutely crucial. Because now that we know our local tools behave identically every single time, we are perfectly set up for our next major milestone, configuring network parameters, where we're going to hook this ultra-reliable local environment right up to remote endpoints and RPCs.
So, I'll leave you with this crucial point to think about. Look at the dev setup you have right now. If your machine crashed entirely today, how many minutes would it take for your script to perfectly rebuild your development environment from scratch? If your answer is, I don't actually have a script, or it would probably take me an entire weekend of painful manual debugging, well, it is time to write your recipe. Idempotent scripts, clear templates, and strict secret separation. That is the gold standard. I highly encourage you to visit forge.college to learn more about this subject, explore our hands-on provisioning templates, and dive deeper into all sorts of other fascinating Web3 topics. Thanks so much for watching this explainer, and happy building!